get started here. So on the agenda for today, we're going to be talking about two new assignments, which will be due both next Tuesday. So assignment 4.5 and 5, discuss quiz 3. Our new topic for this week is talking about arrays, and then we're going to do an in-class assignment on arrays at the end of class. So anything, questions, comments, things you want me to talk about specifically today from the reading or anything else happening now? Okay, so the assignments. So 4.5, you can go over to the content section. It's under week 10. So for assignment 4.5, basically all I want you to do is convert your assignment 4 code to use functions. So you should use one function for each menu choice and for the menu itself. So let's say you have a triangle, that should be inside a triangle function. You have the sum function, that should be in one function. You have the outline one, that should be in a function, so on and so forth. And then a function for the menu itself. So this isn't worth specifically any points on top of it. Well, I should say it's worth 5 bonus points. So you can your grade can just go up if you complete this. So 5 bonus points if you want that. That will be due next Tuesday. There should be a drop box for it on Submit. So or on Dev, you should see that if you look at it. But the big thing that we want to talk about is assignment 5. So this one is a full-blown assignment. So with this one, you are creating a program to calculate the total costs of keychains. Now it just happens to be keychains in my example. You could use any other item if you so choose, or you could make it a generic items. So you could say total cost of items using functions. But the basic functionality is like this. So you prompt a user for the cost of each keychain, prompt the user for the tax rate, allow the user to add, remove, and view their orders as many times as they want to. When the user selects checkout, calculate the total including tax, print the total, and exit. So with this one, you are required to use functions. We have been talking about functions for the past 2 weeks, so that would be a good idea to get you in there and get some good practice. So you need to write these following functions. So you have the add keychain function. So it takes the current keychain count as an argument. So when you're working, writing your function, it needs to take one parameter, and it needs to return type integer, which describes the new keychain count. Same for remove keychain, just the other way around. And then view order takes the current keychain count and the cost, and it prints the number of keychains, the cost of each keychain, and the calculated cost of the order, so without tax. So the only difference between view order and checkout is when we check out, we calculate the tax and we exit. So a user could say view order as many times as they want to, and the program won't exit, it won't calculate tax, it'll just go back to the menu prompt. But as soon as they check out, as soon as they select option number 4, the program is going to exit. And then finally, you need a menu function which prints the menu, prints the prompt, and takes the input from the user. So whichever number they select of the menu option, it takes that number and it returns that number for use in selecting which function to call. So I have the dist assignment 5 as an example. I might be naming that wrong. Yeah, I named it wrong. Let me rename it here quick. So just say dist assignment 5, and you'll open up my calculator. So right when our calculator opens up, prompts for the cost of each keychain. I'll say each keychain is $5.99. That should work. I should have typed $5.99, but that's fine. So our tax rate is going to be 0.07. So we're going to add keychains. Let's say I want to add 5. So now I have 5 keychains. Let's say I want to view the order. So right now, 590 times 5 would give us 29.50. So it gives us the option to keep adding, removing, or viewing the order. So we remove, let's say, 3 keychains. Now we view the order again. You can see our order is now, we have 2 keychains, subtotal is 1180. And finally, we check out. So it prints everything that view current order did, and it also adds in the tax calculation. So this is the total with tax. Then it says thanks for calculating and exits. So not a terribly difficult program, but it does require you to kind of understand how the functions work, how to write functions, things like that. Go going back over here, so worth 10 points, due a week from now. If you don't use functions, you're getting no points. The whole point of this program assignment is to use functions. So do that. Basically everything that's required here is the way it is. There's some leniency on the way menu could work. So one of the things you could do with menu, the way I did it with my example is I had a loop in the main function of our program which actually decided which function we were calling. But what you could do is just repeatedly call menu and actually call the function that the user selects inside of menu. So it's up to you. There's some leniency on how to implement menu, but for the rest of these all need to be just like I state there. So you need to select the right data types too. So like something like count needs to be an integer, it's whole number. Something like costs needs to accept floating point double values, same as tax rate. And when you're printing out, make sure you're printing to two decimal places as well. So that is assignment 5. Again, due a week from today at midnight. Any questions about that right now? Anything that doesn't really make sense? Try out the example. Again, it's not a hard program or anything, not a lot of logic. So yeah, that's assignment 5. Okay. So, also, we're going to have our third quiz this Thursday. So that's going to be mainly over functions and reading function code. So by Thursday, you should make sure you really understand what's going on with functions. I'm going to ask you a few things that are a little bit tricky, that are dependent on you understanding how functions are working. Remember, we create a variable inside a function, doesn't exist outside the function, things like that. So I might get a little bit tricky and ask you why certain things aren't going to work. So again, really put some time into learning, using, working with functions. So arrays. So before I get started with arrays, wanted to go through all of my slides, I guess. Talk about the reading assignment. So I've been seeing this steady progression of reading assignment completion throughout the entire semester. So I realized that maybe you didn't want to do the reading assignment this week because it was Easter break or whatever, but there is a lot of really good content in the reading assignment. I do really generally like the text. I think it really helps augment this course a lot because me explaining something my way doesn't necessarily help everybody, but if you get in the reading assignment and if you look at it, it really is beneficial. I realize it's not that many points. Losing a couple points on each reading assignment isn't going to really negatively impact your grade, but if you're missing all the reading assignments, like it is a significant number of points that probably adds up to 15 or 20. So like get in there, do the reading assignment. Since there is such low completion this time around, I'll give you until Thursday to get it done, but it's good stuff. If you don't understand everything, that's fine. If you don't get everything done, that's fine. I don't expect you to get 100% or anything. So I was taking like full credit, like 70% this last time around for user-defined functions. But really get in there, like it shouldn't be that much work, and it's really good for everyone involved. So let's start talking about arrays then. So arrays hold a fixed number of similar elements together. So when I say fixed, I mean we have to specify the number of elements that we want in each array. So when I say similar, I mean of the same type. So we can group a bunch of different elements together so long as they are the same type. And when we say together, we mean under the same variable name. So let's talk about why we want to use arrays. So let's say I have just a bunch of variables. A, int B, int C, int D, and so on and so forth. And I just have a whole block full of variables like this, and I'm doing stuff with them. I'm storing values in them, just generally manipulating them. One of the reasons we can use we want to use arrays is if we have a bunch of variables which are storing the same type of data that we're using the same calculation on, we could take this entire block, so we get 4 variables here, and we could simplify that down to one array. So I could say int array or my array, and then the number of elements I want. So this has the same number of available positions as those individual declarations that I had before, but with this, they're all organized under this same name. All right. So when we are declaring an array, we say the data type, so the type of data that we want, the variable name, and the number of elements inside the brackets here. So if I was to say int my array and then specify 10 inside the brackets, that's going to allow us to use 10 positions. So one thing to note with arrays is we do start our numbering at 0. So when we say 10 positions, that means I have positions 0 through 9 available to me. And I could change the data type if I wanted to. So double or int or whatever data you want to store in the array. That's valid. And this will only have 5 positions, so 0 through 4 positions. So when I say 0 through 9 or something like that, let's go ahead and make an array with 10 positions. I mean to say my array at position 0. Now, any other place, we've talked about where we can use variable names, literals, function calls to give us values. Anywhere we can use any other variable, we can use something like this. So again, let's say we had a variable int a equals 10, int b equals 20, and we'll have int c, and let's say we want to just calculate a plus b. All right, that's how we would do it with normal variables, and this is the exact equivalent with variables. Let's take, or arrays I should say. Let's take and allocate an array of 3 positions, and let's say my array at position 0 equals 10, my array at position 1 equals 20, and then finally we'll do our addition and say my array at position 3 equals my array position 0 plus my array at position 1. So essentially these 2 blocks of code are equivalent. So just think about it this way. Any place we can use a variable, we can use an array like this as well. It gets a little bit more tricky when we're working with functions, but we'll come back to that later. So again, these are completely equivalent. There's 3 memory positions, 3 positions to store values. The only difference between having individual variables like this and having it like this is everything is under one name. So all of the data is collected together, really. All right. So again, array indexing starts at 0. 10 will give us 0 through 9 positions. So one thing that you might do is you see you have 3 here. Do you remember that it's not like this? We can't do this. Like it doesn't start at 1. This is wrong. It might work, but it's wrong. We do start at 0. So for our size array of 3, this is the only 3 positions that we can touch. Again, we can't do something like this. If we reference position 3, that will result in behavior that breaks things, doesn't really work. So again, 0, 1, 2, 0, 1, 2 for a size 3. Let's say we had size 4. We could say my array at 3 because we have n minus 1 indexes. We have 4 total positions, but our indexing does start at 0. So again, talked about that. So we can use arrays just like any other variable. So anywhere we can put an integer, even like passing it to a function or anything, as long as the data type matches what we are passing it to, then we can do that. So this is what it looks like when we have an array. So let's say we declare an array of 10 integers. What that's going to result in is each of these positions and an empty location for each of those positions. So let's say I say my array at position 0 equals 10. What we're going to do is we're going to find position 0 and we're going to store 10 there. So operating on that array again, let's say we saw position 9, we stored 11 there, so we still have that 10 in position 0. Now we go and we find position 9 and we store that 11 there. But if we try and say, again, my array at position 10, that's bigger than the number of spaces that we have. It's invalid, out of bounds, and you might get an error saying segmentation fault and your program might exit. Might not, probably will. It depends on how your program is laid out. So one of the most important things that we're going to do with arrays is work with for loops. So what I'm going to do here is show you how you take an array with 5 positions and fill all positions with incrementing values using this example first, and then we'll come back and we'll look at this one again. So the resulting array should look something like this. So position 0 will have 0, 1, 1, 2, 2, 3, 3, and 4, 4. So we'll need that index variable for our loop. So I'll say for I equals 0, I is less than 4, plus plus I. Just for debugging purposes, I'll say filling position %i with %i. We'll come back and we'll change things later. So position I with I. So we're going to find position I. And we're going to put I inside I, or that array at that position. That's fine. So we can see it goes through and it fills each position. So remember, when we say our loop is less than 4, remember that I is never going to actually be used at 4. It's only going to be used at 3. If we had something like 5, remember, and if we had 5 positions to fill, remember we could either say less than or equal to 4, or we could say less than 5. So either of those are equivalent. Just remember that. So same deal. So now that we've filled the array, let's go through and quickly print it out. I'm just going to switch back to my old numbers here, so things are more normal. So what we're going to do is, again, set I equal to 0, I is less than 4, increment I, and then what we're going to do is say printf position I is position I. So this should say I. We will print our index, and then we will print my array at I. So prints out as expected. Let's say we wanted to go change this around the other way. We could start at 3, go down to 0 if we wanted to, print it out the other way around. And I incremented my index instead of decremented it. So you see, once we're referencing positions out of bounds with our array, eventually we'll get a segmentation fault. I gotta recompile it. Now it should work. Yeah, so we can print it backwards, forwards, so on and so forth. But one of the good things about arrays is once you fill them with numbers, once they have the numbers there, you don't have to reacquire those numbers from the user. You don't have to regenerate those numbers. You can just keep operating on those numbers over and over again. So eventually what we're going to do is there'll probably be an assignment, I think it's on Thursday, that we'll start working on, where we will read in a number of users from a number of numbers from the user. We'll store them in an array, And then we'll loop through the array repeatedly to do certain statistics on those numbers, such as sum, min, max, maybe range, things like that. But in order to do that, we have to store those numbers so we can use them repeatedly. Let's say we wanted to just do one thing like sum or like max or something like that. If we read in the numbers one time, we could do one thing. But in order to do those operations multiple times, we have to save those numbers. And instead of having a bunch of different variables, which we can't really control where we're storing things, we have to hard code where we want to store values if we're using individual variables. We can instead use a for loop and iterate through each position of the array, storing each new value inside that array. So the other thing we should talk about is this other initialization statement. So let's say we wanted to, again, take this array of 5 positions and give it values. So we can either go through a for loop, generate a range programmatically, or we can statically assign these literal variable or literal values. So this is one way of doing it. I'll go down here and I'll say my second array. Again, I have position 4, and we'll do the same thing like this. So we'll say 0, 1, 2, 3. So if you want to assign a number of values to an array, you can do it that way as well. This way is much better if you want to assign, let's say, just arbitrary numbers that don't really have any rhyme or reason. So let's say you wanted to store like 100 and like 10 and like 222 and 30. You can't really generate those numbers with a for loop or anything like that. You could set each individual position to those numbers. So saying something like this is equivalent to saying something like this. At position 0 equals 100, position 1 equal 10, so, and so on and so forth. So that would continue on there with the, sorry, I messed up here, with the second and third position also being set. And those two are equivalent. It's just this is a shorthand way of assigning a bunch of values to an array very fast, as opposed to doing it like this, which takes some time. So it's worth noting you can only do this when you originally create the array. So you can't do something like this. You can't go again and say my second array equals 10, 20, 30, 40. So you can't do something like that. You can only use this special initialization thing when you first declare the array with its size. So you can't give it values again after you've first declared it. So those are 2 ways we can really, well, I guess there's 3 ways there. You can reference each individual position. You could reference each position through a for loop, or you could use this setup with the literals and the static initialization, I would call it. So regardless, you'll always result in an array model that looks like this. So either way here, if you assign it with the for loop or assign it like this, you're going to get an array that looks just like this. So next thing we want to talk about is passing arrays to functions. So we can pass arrays to functions, but the thing that we have to deal with when passing an array to a function is with its size. So the one thing that we have to manage and see that is not managed for us is the size of the array. So once we've declared an array, there's no counter or anything that describes how big that array is. Once it exists, we have to keep track of how big it is on its own. So something we might want to do is have a variable like called len and set it equal to how long that array is. So let's say we do this, we'll keep this here. We will fill that array with 0 through 3. And then let's write a function to take that array. What this function is going to do is, let's just say it's going to sum up all the numbers. Or what did I do in my example over here? I did an int over here. I'll do sum. That's a good one. So in order to pass an array to a function, we need to say the data type, we need to say the variable name. We put brackets here, but we don't actually put how big the array is. So we might do something like this. Doesn't work like that. All we do is we pass using brackets. And then we'll also need to keep track of the length of the array when we're passing our arguments in. So I need to change my name here. I don't think I can have those be the same. So we'll say sum equals 0. We need an index to iterate through all of the positions of the array. So say for I equals 0, I is less than len increment I. And even though we didn't specify the number or any position up here, we can still reference any available positions. And the only thing that's limited by is the len that we passed in. So let's say we had created an array with 5 positions or something, and we'd said len is 10 or 20 or something like that. This is going to keep working regardless of the fact that we only have 4 positions actually available for len, or for my array, sorry. So let's just do this. We'll say basically this reads as for each position in the array, we're going to add array at my current position to sum. And then at the very end of this function, what we're going to do is print out our sum. So again, to call that, we need to say sum array, my array, len. So one of the things we have to realize is that when we're passing arrays to functions, we just say the name. We don't say brackets, so we don't reference any specific position inside of the array. So basically, we would do this to pass the entire array. Let's say we had an array. So right in this position, we can pass an array. But let's say we wanted to pass an integer in that array to a function. If we want to pass the value inside of the array, one single value, we would say my array at whatever position that value is at. But in order to pass the entire array, we need to do this. We need to just say the name of the variable. So again, no brackets on it, nothing like that, nothing like that. To pass to a function, you say the entire variable name. So again, in order to accept an array to a function, you need to data type, local variable name, and then brackets. Can't do something like that. That will only accept one value. Let's go ahead and compile it and see if it works. It won't. It will say, well, it'll give us a couple problems. Subscripted value is neither array, pointer, or vector. So basically, you declare your function as taking an integer, and you tried to reference a certain position inside of a single integer as an array. It doesn't work. Integer to pointer, a whole bunch of errors. So again, when we're passing an array in, just put brackets, no number inside of it. Recompile it, works fine without errors. And we can see 0 plus 1 plus 2 plus 3 equals 6. So that's how you'd write a sum function. Now normally what we want to do is, of course, make this function a little bit more reusable. Say our sum array function returns int, and then we'd return the sum at the end instead of just printing it. But for this example, it's fine. So that's how we would use arrays with functions. So a couple of things to note with functions. What did I say here? So just like before, let's say we had this len variable here. We change len inside of the function, not going to change outside of the function. But the one thing to note with arrays is when we pass an array into a function, this array actually gets modified when we leave the function, regardless of whether we return or not. So let's say what we're going to do is I'm not going to rename the function, but what I'm going to do is, instead of adding each position to the sum, what I'm going to do is add 10 to each position. And I'll need to write a loop to go through and print out each position. So we can see that after calling that function, after adding 10 to each position, that actually the array is modified outside of the function. So that's another reason using arrays is good, at least at this point, is we can pass arrays into functions that can be modified and their values will be persistent regardless of where they are. So normally what we would expect with a normal variable, if we pass it in, is we would add 10 to it or something, and that variable would be unchanged outside of the function. The variable that we passed in was a copy. But when we pass an array, we're not really passing a copy, we're passing the actual array itself, and we can modify it as much as we want. So it does add a lot of power to what we can do. We can write functions to do operations over arrays, adding, dividing, multiplying, so on and so forth. Just doing lots of stuff like that. So let's do this. I think I'm all out of examples. Yeah. So one last example before we do our in-class assignment. We'll modify this a little bit. So what I'm going to do is I'm going to actually declare two arrays, both of size 4. Still initializing our one variable to 0, 1, 2, 3, or our one array, I should say. But now what we're going to do, instead of taking one array, we're going to take two arrays. So call it like this. And now what we're going to do is, instead of adding 10 to R up here, we're going to add 10 to R and store it in res. So we're going to say res at position I equals R at position I plus 10. So what this is going to do is, instead of storing the value back in R, it's going to store it in this new res array that we're passing in. So now instead of, well, in addition to, we'll do it in addition to. So in addition to printing my original array, I'll print my res too. And I'll put some nice little headers so you can see what's coming from where. Alright, so go ahead, compile that. I don't think I changed my function name. Yeah. So I need to change this name to match my name of my function up there. So add 10R. You say printf instead of print. And there we go. So we can see my array when we passed in isn't changed, but my res is. So if we want to do operations, we can, of course, the first example that I showed you, doing operations on that array itself. Otherwise, if we want to do operations and have, we want to preserve the original value, then we need to create another array and pass that array in as well. So that's arrays. Any questions? Anything else you want me to talk about with that right now? What? Sure. Anything specific about it, or just want to look at it more? Does that all kind of make sense what we're talking about? And anything that, I mean, I can talk more about any specific area. And it's whether you want me to talk about it now or when you're working on this in-class assignment a little bit. So okay, so what I'm going to do is I'm just going to take this and I'll put it in the dist folder, so you can just have it. That's fine. So what I'm going to do, just put it here. So from your perspective, you can just say nano dist array x.c. And if you want to look at that code anymore, you can. But I'd like to move on and let's do this in-class assignment. So for this in-class assignment, I want you to create 3 arrays with 5 positions each. So fill the first with 0 through 4 and print it out. Fill the second with 4 through 0 and print it out. Fill the third with random numbers 0 through 100. Use for loops. Ideally, you should use functions too. That's up to you. And then submit to day 19. At the very least, the one piece of functionality that you're going to need to repeat for all of these is once you've filled all of these, once you've created them, filled them, at the very end you need to print all of them. So you could write 3 for loops if you wanted to print all of them. Or what you could do is just write a function which looped through all of the positions and printed them out. So I'd recommend that you write at least one function to loop through each position in the array and print each position out. So you could write other functions to fill the other, fill first, second, and third, but that's up to you. So submit to day 19. Don't think I've made it yet, but I will right now. Again, feel free to talk to each other if you want to. Call me over whenever you have any questions. So have fun.